So in the context-aware recommender system, there are three ways to build the algorithm for CARS. Okay, CARS is the context-aware recommender system. The first is pre-filtering, contextual pre-filtering. So based on the data, we have the U, I, C, and R. So what is U? U is the user. Okay. I is the item. C is the context. And R is the rating. So we have at least those 4 columns, and then we can extract the context. So we can extract the context. So we have only the U and I and R. For every context data, yeah, we have the data, user, item, and rating, and then we can do like two-dimensional recommender. This is based on the user and item, and then we can predict the rating. And then we can do the contextual recommendation after we extract this on the user. The other kind of method is the contextual post filtering. The contextual post, so we call pre. What is pre? Is before. Post, it is after. So the data is the same. We have U, C, I, and R. Now you will do the recommender first. So you include all the data and you will recommend based on the U and I. Yeah, we assume that we use the rating information. And after you have those information from this data, we would like to recommend. After we recommend, so we would like to extract based on the context. So the only difference is, we extract in the first time for the pre-filtering, or we extract the context at the last time. There is another method, we call it contextual modeling. In the contextual modeling, we have the data, and then we create the model. So what is the model? The model can be anything. The SVD. So we use the matrix factorization. So using the matrix factorization with the SVD, singular value decomposition, we can make a model, and after we have that model, we can do the contextual recommendation. So it is more advanced to do the recommendation. So let's look how the algorithm works on this recommendation. So next we focus on the two CARS algorithm. The first is the contextual filtering. It means use the context as the filter, and then we can do the recombination. Or the second algorithm is the contextual model. So we will look at the modeling, whether it is independent or dependent. We focus on the context-aware collaborative filtering, because there's also another method for the context-aware content-based filtering. But for the collaborative filtering, we assume we have the rating. So the rating, we assume that we have the explicit rating. If you have implicit rating, it will be also good, but it might be a little bit different. Okay, let's look at the contextual filtering. So in the contextual filtering, there are two approaches. The first is differential context modeling, and the other is splitting approach. In the differential context modeling, let's suppose we have this data. We have user, movie, and then this is the context, time, location, companion, and this is the rating. So user 1, he or she watched Titanic, and he watched the movie on weekend at home and with his girlfriend. The rating he gave to the movie is 4. User 2 watched the Titanic, weekday, home, girlfriend. He gave the rating 5. User 3 was Titanic, weekday, cinema, sister, and he gave the rating 4. Now, there's one question. If the user 1 watched again, maybe user 1 watched the movie again, Titanic, but now he watched on the weekday and he was at home, and now he is watching with his sister. So what is the rating? Is it still 4 or is it different? So we need to find the context matching. What is the context matching? In this case, we have this context because we want to predict based on this requirement. So the profiles is weekday, home, and sister. The question is there any other user who have the similar profiles? Weekday, home, girlfriend. Okay, no. What about this? Oh, this is weekend. Okay, this is also no. This one weekday. Okay, cinema. No. Then no profiles have the same with this profile. Then what can we do? We have another method. We call it context relaxation. Let's use a subset of context dimension events. A subset of context dimension means if we cannot provide all those 3, let's find the subset, maybe only 2. If the time and location is not possible, maybe let's find the time and companion, and so on. And there is another way, we call it context weighting. Context weighting means use all profiles. So we can use all the profiles, but weighted by the context similarity. Let's look one by one. In short, it is the same with the previous one. In short, we want to use a subset of rating profiles in the collaborative filtering. So the idea is still using the collaborative filtering. Do you still remember the collaborative filtering? In the first part, we already learned the collaborative filtering, but now we are just using the subset of rating profiles. So there are some research applied such filter to user KNN or item KNN. What does it mean? This is user K nearest neighbor. The K nearest neighbor, it means I want to find K, let's say 2. So I want to find 2 nearest neighbor from that user. We have item K and N. So it is also item K nearest neighbor. So what is the item that is similar to that item in the given context? But there are two main drawbacks. So if we just use the user or item KNN, they just apply context as filter in one component. For example, the neighborhood selection. They just use the same selected context as filters. For example, different context dimension may be useful for different components. So in this case, we are going to look at the relaxation. So the first relaxation, if I use the time, location, and companion, it will be 0 record match. Okay. There is no record match with this one. Now, if I try to relax only time and location, weekday and home, okay, we have user 2. If we use the time and location only, user 2 match. How about if I use only time? If I use only time, weekday, so there are 2 users match. Okay. So we need to find this kind of matching by looking the number of record that match. If it is available, okay, we can say that this context can be used. If not available, like this one, then we skip it. So we have the DCR. Oh, why I don't put this one? Oh, sorry, I don't put this one. DCR. DCR is the differential context relaxation. So we want to discuss the relaxation here. In DCR, in the differential context relaxation, we instead select only neighbors as NC1 who have issued their ratings for I in the context matching C under the relaxation C1. So we have a kind of condition. We have a kind of condition that can relax this context. After we relax, so we have the time and location. Okay, then we will just use the time and location because it is one match. So we just use the possible data, in this case, this one. So if we have this one, then what happened next? We will compute the RU. Sorry, I cannot make the RU like this. This RU like this. So the computation of R bar U in the original equation is replaced by the one in which this average baseline rating for user U is computed using a filter set of ratings by the constraint C2. So at the first one, we have the C1. It is based on the context. And now we want to get only the user based on the constraint C2. So it means only based on the value based on the time and value based on the location, because we have time and location one match, and we want to look for this condition. And then the computation of R bar A in the original equation, we replace with 1 using the filter rating of the user A as above, or we call this is the R bar A. So if you still remember in the Pearson correlation, so when we want to predict the rating, we will get the R bar. What is R bar? It is the average rating. So it is the average rating from this user. If you still remember when we do the first one, we have user 1, user 2, user 3, user 4, and we have Alice. And Alice, we have item 1, item 2, item 3, item 4, item 5, and then we have question on Alice. And then when we want to predict this one, we do the average of the rating of Alice. So this is also the same. We are making the average of the user 1. We are doing the average of the user 1 given the C3. It means we want to find the user 1 that have the context. So we do not need to calculate all the average. We do not need to calculate all, but we just calculate the average based on the context. After we have the average based on the context, we do the same calculation with the collaborative filtering that we have before by subtracting the rating of other user. So if it is closer to user 4, closer to user 3, then we will check the rating. We will check the rating of this item minus by the R bar U. R bar U given the C2. C2 is the context based on the column and the row. So it means I will check the rating, this one, minus by the RU, and then I will check also the rating, this one. Maybe this one is RU3, and then this is R bar U4. For every of this subtraction, we will multiply with the similarity method. So the formula is the same with the one that we learned in the collaborative filtering. The difference is only now pay attention to the given context. So the given context is based on this one. If I'm looking for the time and location, I will use the time and location. If I use only the time, then I will just use the time to look for the prediction. In the context weighting, it is based on the similarity. Based on the similarity given the context of the person or the user. For example, now I would like to find the similarity of context by using the weighted Jaccard similarity. In this case, I would like to use I would like to see the similarity between these one. So C and D, okay, it means I want to find the similarity between this and this one. And then tau is the weighting factors, because I have 1, 2, 3. So I would like to put the weight 1, weight 2, and weight 3. So let's just assume that every attribute is important. Then I have the weight 1 is the same with weight 2 and the same with weight 3 equals to 1. Then I would like to do the Jaccard similarity. What is the Jaccard similarity? Let's find the similar value between those two, weekday and weekday. Okay, it is the same. Home and home. Okay, it is the same. Girlfriend and sister. So it is different. It means the number of all match dimension divided by the number of all dimensions. So it is 2 which are matched among 3 different dimensions. Okay. So we have that the similarity of those two is 2 divided by 2. Now, in the context weighting, it is like more complicated. Okay. We want to find the context value. So after I consider with the examples, I think I will just give you this formula. Okay. And how they obtain this formula. This is the basic algorithm in the collaborative filtering. So if you still remember, like I mentioned before, the RA is the average of the user A. In this case, Alice. Okay. We have the average of user A. And then let's find the neighbor contribution. The neighbor contribution is the rating of user in that particular item. So in the user 3 and 4, let's say this one and this one, we will minus with the average, and then multiply with the similarity. So the notion differential here is we want to apply the different context relaxation and context weighting to each of the component. So the user baseline, it will be split or it will be differentiated. We call it differentiate. What does it mean by differentiate? In this case, the user baseline, it can be differentiated to different contexts. So we do not use the common average. So we will use the average when the context is correct. The neighbor selection, this is also the same. We want to differentiate. So the differentiate of the neighbor selection, it is based also on the different contexts. The neighborhood contribution, we want to also differentiate based on the contribution of this particular context. And the user similarity is also will be differentiated. So how many contexts do you have? It will depend on the similarity measures. So if you want to know more about this one, I can recommend you to look at this paper, okay, recommendation with differential context weighting. So it explains how you can get this row minus by row bar. Okay. Row bar means the rating given by the average of particular items multiplied by the similarity. And then we divide with the similarity for all the items given based on the context. There's another way, for the differential context modeling. You just want to make differentiation from the collaborative filtering. For the context-aware splitting approach, let's see another example. User 1 watch movie M1. The location is in the pool. And user 1 gave rating 5. User 2 watched the same movie M1 in the pool. He gave rating 5. User 3 watched movie M1 in the pool and he also gave rating 5. User 1, again, he watched the movie 1, but now the location is at home and the rating is 2. User 4 gave watched movie 1 at home and the rating is 3. User 2 watched movie 1 and he is in the cinema and the rating is 2. So if you look at this one, those are high rating and those are low rating. It was the same movie. It have different IDs and different contexts. So based on this background, one researchers, they try to split it. The transformation, okay, they want to split. So they will include this location information into the item. How? Because we know that those are high ratings and those are low ratings, we know this is the movie M1. So we give more information to M1, which is M11. It means this M11, it is a movie one, and all users watch in the location one, or which is full. So this is M11, M1. What about this one? They put M12. Why? Because it is belong on the low rating, and the user watch this movie in another location, which is at home. Now you can see M1 at home, and it is M12. Now we have M1 and the location is in the cinema, but it is M12. Why? If the location is home, home is M12, M12, but here is M12. Meanwhile, the location is cinema. Why? Not full. Okay, good. Because we want to make only two different locations, full or not full. Okay, so that's why this is 1 and this is 2. So you can also have different kind of feature extraction. Okay, we call this is the feature extraction, or we call this is the splitting approach. So how to find this split? Because you can also have full or non-full. You can also have home, non-home. Now, which one is the best and optimal split? In the splitting criteria, there are some kind of tests. So they have the impurity criteria and significant tests. You still remember impurity criteria? In the information gain, if you look at the information gain formula, it is based on the information theory or the entropy. So the entropy value in the data mining, if you learn from the decision tree, it shows like the minus pi minus sigma of pi multiplied by log of pi. So this kind of entropy is available for the impurity criteria. So therefore impurity criteria by splitting. So you can use the t-test. I think you learned already in the statistics. Z-test. I think you also learned in the statistics. Chi-square test. You learn in the data mining and the information gain. This is also in the data mining. So if you use the tests, like say in the statistical test, yeah. Let's say I'm using the t-mean, the t-test. So it is the two sample t-test and computes how significantly different are the means of the rating in the two rating subsets when the split C. So C is the context condition. For example, location pool is used. So the bigger the t-value of the test is, the more likely the difference of the means in the two partition is significant. So it depends on the alpha. Let's say you have the 95% confidence, then yeah, you can get the p value. And you need to choose the largest one. You need to choose the t min, which is the highest one. Oh. Okay, in this case, yeah, I didn't give you the example, but in this case, what is the average of this one? If it is full, then the average is 5. If it is non-full, the average is 2 plus 2 plus 3 divided by 3. Okay, 7 divided by 3, then it's like 2.3. Then we can do the significant test. 5, is it equal to 2.3? Okay, with the statistical test, we know that this is not equal, then we can use the splitting. We can use the full or non-full. We can use another way, home and non-home. So in this case, 2 plus 3 divided by 2. And then non-home is 5 multiplied by 3 is 15 plus 2 divided by 4. So the result is 4 point something, 4.75. And then we have 2.5. Oh, this is also significant difference. So we need to choose the highest one. Okay. If we know this one and then the other, it was 2.3 compared to 5. And then again, we check with different options. Cinema, non-cinema. So which one is the highest T min, then it will be chosen for the splitting. Sometimes, yeah, people also use the very simple splitting. They simply splitting by item, or they can simply splitting by user, or they can splitting by user item. In this case, user 1, yeah, T1 is giving a rating 3. He is on the weekend, home and friend. User 1, T1, 5, it is in weekend, cinema and girlfriend. What about this one? U1, T1, and what's the rating? Given that the time is weekday and the location is at home and the companion is family. So if we want to split by the item, if we split by the item, we can split like this one. So this is item T1. Okay. What is the item that we want to consider this? So T2, T12 means item that more have relevancy to the context given in the difference. And then this one, yeah, we want to check because it is based on the time. So this one is, this one is based on the location. Okay, for example, this one is based on the location. So they give the same T1, T11. So T12 because it is in the different location. Or you want to split by the user. If you want to split by the user, so user 12, user 12, user 11. User 12 means user 1. Where is, for example, we know this item. Okay. It is on weekend. It is on weekend. Okay. It is on weekday. So user 12, user 12, and this is user 11. or you want to use the user and item splitting. So it views dependent context to user and item simultaneously at the same time. So if you want to know the user one with the respective time and the item with the respective location, then you can have user 12 with T11, user 12 with T12, and now user 11 with T11. So using this one, we can try to predict trading. Okay, I think I will stop here because this one is using the matrix factorization. Okay, any questions? Okay. If not,